Howdy. Today we'll look at AetherMart Milestone 4 Advanced AI-driven e-commerce data platform. In this milestone, we are going to achieve high availability, uh, improved data quality, and semantic search with vector AI integration. Today we'll be looking at cluster optimization, ETL, vector AI integration, high availability, and data quality. So this is the milestone overview up till now. Uh, First, it was the project context, then optimization goals, then ELT pipeline development, and fourth is the AI and security enhancements that we'll be doing with MariaDB Vector AI. So a quick recap on milestone 3. In milestone 3, we saw the deployment of Galera cluster uh, and data integrity verification. It was automatic failover implementation that we tested in milestone 3 and the resilient platform establishment. So I'll quickly show you, take you to the instance. And I have actually prepared a document uh, that's a README document, and I'll walk you through that for the milestone 4. So as a first step, we need to edit the security group to include the 3306 port uh, to and along with that we need to keep the port 22 open. This is because if we just keep the 3306, it exposes our database to the attackers. And earlier, when we were using the faker library, uh, the data in the products table was just random words, for example, sunset or eating, which was not at all inclined to what we needed. That's why to get a more real world like data, I used faker commerce library to get uh, more real world like products names. Yeah. So this is the code that I used to generate the script for to generate the data for the product table. Additionally, I had created the user to access the database uh, through any local host. Yeah. These are the quick tests that I ran before starting the milestone today, the recording. So yeah, so the uh, first let's check if we already have the cluster up and running. So for that we go into the MariaDB and we use the code show status for that. As you can see, our cluster size is 3, which means that our cluster is already connected. Our all three instances are active and are already connected. So the cluster is active. Additionally, I performed other checks for testing. So this was for split brain detection. As you can see, the local state comment is synced and the WS rep is connected. It's on. And additionally, to identify any query bottlenecks in the products table, I use this query. As you can see, it's all up and running. If you see using file sort or full table scan, create an index. So if we want, we can create an index on this. So the query ran perfectly, and now everything is indexed. Similarly, we can do for the customer order query. And to show the status of the system level performance, I ran these codes. This will help identify a better solution and create more better debugging scenarios for us, and we can identify where exactly uh, are we achieving what we intended to. As you can see here, the number of slow queries that I have is 0. That means our queries are running perfectly fine and are getting the perfect speed. So this is a quick summary for that rubric. Identify and troubleshoot cluster issues. We use WS rep variables, Galera logs, and node restarts. Performance analysis used explain, show status, system bench, and MariaDB monitor. Bottlenecks found, unindexed joins, table scans, replication lag. Fixes applied, added indexes. uh, Tuned buffer pool, optimized queries, rebalanced nodes, verification, rerun queries, and suspense to confirm latency reduction. So after optimizations, recheck. So the slow queries is 0 and the number of queries is 304. Moving on to the robust pipeline architecture. Before optimizing multiple full scans leading to high input output and latency, slow queries impacting user experience. Unfortunately, this was not the issue because we had no slow queries. And after optimization, index joins replacing full scans, 0 slow queries detected, improved cache hit ratio, enhancing response times. So to achieve that, let's go back to the instance. So I created a vectordb.env file where I use the same credentials as the as myself, the host, and the student password. I created the user, right? So uh, in that, I created and ran a generator to file and milestone for Python scripts. Uh, so I'll quickly show you the script and walk you through that. So here, as you can see, we are using the Python script. I'll quickly open the generator. So here the number of customers 100, and these are all the values that we are taking. The data generation is happening over here. This is the categories list. So here we are reading and reading all the files, and we are creating a staging table. And I loaded that file in the virtual environment that I'm using for Python. So I ran the script, it ran perfectly fine. And secondly, uh, we are creating, this was the second Python script that we are running for configuration. This will help us create staging tables that I was previously saying. We'll be using ELT pipeline class for this because every time we load it, we'll have to transform it because we are transforming after we are loading the entire data. This is for the schema setup. That this is the code that AI has given me and I have defined multiple times. These are for all the CSV files that we are using. These are the staging tables. And yeah, so load to staging. So staging is basically when we are using temporary tables to perform the transformation tasks for ELT, because we'll extract from the source, we'll load it into a stage table, we'll perform all the transformations, and then we'll load it to the replica. So first we are loading to staging table, and the second step is, and we are even verifying the load, so it just gives a double check. Then we are transforming the data, like I just previously told, and third we are putting into production, loading to production. Audit logging helps us to just identify where we are going wrong. So now coming back to the instance, so I'll quickly run the file again. I'm not sure what file was it. It's milestone4.py. Oh, the database connection closed. Unfortunately, this might have occurred because of the .env file. Anyway, I did run it earlier, so I can just show you that. So this was the output that it had given earlier. So, and it showed that the pipeline is complete. So we staged 10 table, 10 rows, and it loaded 10 rows. Everything went perfectly fine, so it's fine. And we did even find invalid rows of 22. We did find 22 invalid rows, so it helps us to just identify and know what the bottlenecks are. Moving on to the transformation that we just spoke. So this was the pipeline. Create a multi-stage automated pipeline ensuring data accuracy and auditability. Data flow process was CSV we generated using the generator script. Then staging, transformation, and production. Then audit logging for traceability, like I just mentioned in the code. Data quality assurance, and pipeline robustness and monitoring. So now for the vector implementation. We started with editing the security group, like I mentioned earlier, and we created the faker commerce uh, generator script. to load the entire data, and we created the user, like I mentioned. This was the um, virtual environment. So we ran this pip install, like professor had mentioned. Uh, yeah, this was because we are using Google Gemini to interact with our database. Google Gemini's API key. So yeah, moving on. So these were all the installations that were required. These are just the troubleshooting methods that I uh, have written here because I was facing these issues multiple times, and I thought of just jotting all the points down because it will be beneficial for anyone who will read this document. So this is the Google API key. This is the code that I was using, and I have even mentioned like the steps where you need to perform the steps, right? Okay. We altered the tables. We added the columns with vector data type, and we are using 768 dimensions. Yeah. So create a new gen prod description and embed.py file to generate product descriptions. So when I loaded this on my instance, it ran for 15 minutes. So I do have a snippet of it that I would like to show you guys. So I ran the entire thing in multiple batches. Yeah. So this is the code that I used, and this is a part of the implementation process. So I divided the entire products. I took 50 products and I divided them into 10 batches of 5 products each. So this is just the first batch, and yeah, so successfully uh, the first batch was successful upon completion, and then I added a wait time of 60 seconds, 1 minute before the second batch starts. So this just goes on for like 15 minutes, and later the entire batch was successful. The batch processing was successful. Moving on. Later, we did the similarity search that uh, helps to identify the uh, product um, similarity using the query. Uh, I'll quickly close this. So this was going on, so I'll just quickly close this snippet. Yeah. Mm, and let's take you back to the instance. Mhm. Yeah. So this was the code, and the first option that I chose was search by text query. So let's go there. One, enter your search query. I will search food. Number of results, say 5. So it will give a list. So as you can see, the first is granite chicken, then chicken, fresh pizza, chips, sausages. So the similarity score is 0.4, which is just 41% accuracy because of the data that we loaded. Moving on. So this was the vector integration flow, pipeline orchestration, Python-based ALT script, like I mentioned, orchestrates the pipeline, execution tracking, automatic logging of row counts, runtime, and success failure status, customers fully valid, validation summary, orders and reviews. The screenshot, the screenshot was not necessary because I showed you the order file, right? Okay. Even though I do have the screenshots. Anyway, let's move on. The semantic search demo that we just saw. Feature engineering with Google Gemini AI. Semantic representation enhancement. We are using Vector 768. Uh, Data preparation for machine learning. API call robustness. We implemented exponential backup for API calls to handle transient failures. Batch embedding success rate. Semantic search demo overview. ENN, approximate nearest neighbor. So the speed of our search is powered by approximate nearest neighbor, or ANN concept. ANN provides a fast search for similar vectors by using graph shortcuts. It is slightly less accurate than an exact search, but is orders of magnitude faster, essential for real-time applications. Our implementation uses HNSW, or hierarchical navigable small world, multi-layer graph index. To top layers provide The top layers provide coarse shortcuts across the vector space, while the bottom layers provide precise neighbors. In our index definition, m is equal to 16 specifies the number of neighbors checked per layer, and the distance is cosine. Uh, that is the metric that we are using for measuring similarity. This system provides sub-millisecond semantic search performance. Yeah. Our batch achieved a 95% success rate with an average processing time of about 8 seconds per product. We observed high similarity scores, often above zero point 0.9 for close semantic searches. This, sorry, matches. This complete and validated set of embeddings establishes a strong foundation for future AI recommendations. So security and compliance, how HNSW organizes vectors into multi-layered graphs for efficient navigation. The part that I just told. Key lessons learned: indexing is critical for Galera. ANN enables real-time AI. ETL auditability ensures traceability. Robust AI pipeline handling, we just saw, and clean data means better embeddings. AI disclosure and lessons learned. So AI, Gemini, Claude, and ChatGPT as a collaborative partner helped me in throughout Milestone 4. They helped me generate code. Uh, it was for interactive debugging support and conceptual clarification and analysis. Strategic focus enabled by AI. Uh, it helped for better problem solving. In fact, even the presentation is developed by AI. Conclusion and future vision: tools utilize Google Gemini generative AI for product description enrichment, LangChain combined with MariaDB vector for embedding computation and search, data privacy measures, no personal data processed or stored since we everything was through Faker. It was all dummy data. Uh, Primary use cases, generate rich contextual product descriptions, rate limiting safeguards, API logging, conclusion and future vision. So the tool use cases and safeguards collectively contribute to a robust and secure system. Future vision includes expanding capabilities while maintaining high standards of security and efficiency. Um, that's all for the milestone from my end. Thank you so much. Please reach out if you guys have any questions. Have a great day.